The Sun, a blazing ball of plasma at the heart of our solar system, is the source of life as we know it. This massive star, composed primarily of hydrogen and helium, undergoes nuclear fusion in its core, producing an immense amount of energy. This energy radiates outward, reaching every corner of our solar system and beyond. This gigantic star bathes our planet in warmth and light, providing the energy necessary for plants to grow, animals to thrive, and humans to exist. The sun's rays drive the process of photosynthesis, enabling plants to convert sunlight into chemical energy, which forms the base of the food chain. Without this energy, life on Earth would not be possible. Its gravitational pull keeps Earth and the other planets locked in orbit, dictating the rhythm of our days and years. The sun's gravity is so powerful that it governs the motion of all the celestial bodies within our solar system, from the smallest asteroid to the largest planet. This gravitational force ensures that the planets follow predictable paths, creating a stable environment for life to flourish. The sun's influence extends far beyond our planet, shaping the environment of the entire solar system. Its gravitational field holds the solar system together, while its light and heat affect the atmospheres and surfaces of other planets and moons. The sun's energy drives weather patterns, climate, and even geological processes on Earth and other celestial bodies. Its powerful solar wind, a stream of charged particles constantly flowing from its surface, interacts with planetary atmospheres and creates stunning auroras. These mesmerizing light displays, known as the northern and southern lights, occur when solar wind particles collide with Earth's magnetic field, causing the atmosphere to glow in vibrant colors. The solar wind also shapes the magnetospheres of other planets, influencing their space weather and protecting them from cosmic radiation. Without the sun, our solar system would be a vastly different and far less hospitable place. The absence of its light and heat would plunge our world into darkness and extreme cold, making it impossible for life as we know it to survive. The sun's presence is essential for maintaining the delicate balance that allows our planet to sustain life. Its energy drives the water cycle, powers the winds, and supports the diverse ecosystems that make Earth unique. The sun truly is the heart of our solar system, a dynamic and life-giving force that shapes our existence in countless ways. Stars, like living organisms, go through a life cycle of birth, growth, maturity, and eventually death. This journey begins in vast clouds of gas and dust, known as nebulae, where gravity pulls the material together to form a protostar. Over time, the protostar's core heats up, igniting nuclear fusion and giving birth to a new star. These cycles are governed by the delicate balance between gravity, which pulls matter inward, and nuclear fusion, which pushes matter outward. Gravity's relentless pull compresses the star's core, while the energy from nuclear fusion creates an outward pressure that counteracts this force, maintaining the star's stability. For much of their lives, stars exist in a state of equilibrium, fusing hydrogen into helium in their cores and radiating energy into space. This stable phase can last for millions to billions of years, depending on the star's mass. During this time, stars shine brightly, providing light and warmth to any surrounding planets. As stars age, they consume their hydrogen fuel, leading to changes in their internal structure and outward appearance. The core contracts and heats up, while the outer layers expand and cool. This transformation marks the beginning of the end for the star. Smaller stars, like our Sun, gradually expand and cool, transforming into red giants. In this phase, the star's outer layers are pushed outward, causing it to swell to many times its original size. The star's color changes to a reddish hue as it cools. These giants eventually shed their outer layers, leaving behind a dense core known as a white dwarf. This remnant is incredibly hot and dense, slowly cooling and fading over billions of years. The journey of a star is a testament to the dynamic and ever-changing nature of the universe, a cycle of creation and transformation that continues to shape the cosmos. Massive stars, however, meet a far more dramatic end. As they exhaust their fuel reserves, their cores collapse under their own immense gravity. This collapse triggers a catastrophic explosion, known as a supernova, that can outshine an entire galaxy for a brief period. Supernovae are among the most energetic events in the universe, releasing immense amounts of energy and scattering heavy elements into space. These elements, forged in the hearts of dying stars, become the building blocks for new stars, planets, and even life itself. Fortunately, our Sun is not massive enough to go supernova. However, imagining such a scenario allows us to explore the profound interconnectedness of our solar system and the devastating consequences of cosmic events. While the Sun's eventual demise is billions of years in the future, contemplating this hypothetical scenario underscores our reliance on this celestial giant and prompts us to appreciate the delicate balance that sustains life on Earth. If the Sun were to suddenly explode, the first sign on Earth would be the abrupt cessation of sunlight, plunging our planet into darkness after a delay of roughly 8 minutes, the time it takes for light to travel from the Sun to Earth. This sudden darkness would be accompanied by a surge of intense radiation as the shock wave from the supernova reaches our planet. This radiation would disrupt communications, disable satellites, and pose a severe threat to all living organisms. In the aftermath of the initial blast, Earth would experience a rapid and catastrophic drop in temperature. Without the Sun's warmth, our planet would quickly transform into a frozen wasteland. Oceans would freeze over, plants would wither and die, and animals would succumb to the extreme cold. The delicate balance of Earth's ecosystems would be irrevocably disrupted, leading to mass extinctions across the globe. Life after the Sun, long-term ramifications. In the long term, the absence of the Sun's gravitational pull would send Earth hurtling out of its orbit, adrift in the vast expanse of space. Our planet would become a rogue world, wandering the cosmos in perpetual darkness and coldness. Any surviving life forms would need to adapt to these incredibly harsh conditions, perhaps retreating to deep underground environments or finding other sources of energy to sustain themselves. Cosmic sentinels monitoring the universe for explosions. While the scenario of our Sun exploding is highly unlikely, astronomers are constantly monitoring the universe for supernovae and other cosmic events. Using powerful telescopes, both on Earth and in space, they scan the skies for telltale signs of these explosions. Studying supernovae provides valuable insights into the life cycles of stars, the origins of heavy elements, and the evolution of galaxies. By observing these distant explosions, we gain a deeper understanding of our own place in the cosmos. Preparing for the unthinkable. Can we survive a supernova? The immense power of a supernova underscores the fragility of life in the universe. While we cannot prevent such events, understanding them better allows us to prepare for other potential cosmic threats, such as asteroid impacts or gamma-ray bursts. Furthermore, exploring the possibility of life on other planets and potentially colonizing them could ensure the survival of our species, even if our own solar system were to become uninhabitable. Our place in the cosmos, reflections on stellar explosions. Contemplating the hypothetical explosion of our Sun serves as a humbling reminder of our place in the vast and ever-changing universe. The Sun, a seemingly eternal source of light and warmth, is but a transient entity in the grand scheme of cosmic time. Its eventual demise, though billions of years away, is a stark reminder of the impermanence of all things. It highlights our dependence on the delicate balance of cosmic forces and the interconnectedness of all things in the cosmos. The gravitational pull that keeps our planets in orbit, the solar winds that shape our atmosphere, and the magnetic fields that protect us from harmful radiation. All these elements work in harmony to sustain life on Earth. By studying stellar explosions and other cosmic phenomena, we gain a deeper appreciation for the beauty and wonder of the universe. Supernovae, for instance, are not just cataclysmic events, they are also the forges where elements heavier than iron are created, seeding the cosmos with the building blocks of planets and life. As we observe these magnificent events from the safety of our small blue planet, we are reminded of the fragility and preciousness of life on Earth. The more we learn about the universe, the more we understand the delicate conditions that make our existence possible. This knowledge not only enriches our scientific understanding, but also deepens our sense of connection to the cosmos and our responsibility to protect our home.